scientific notation in international language. It's just called standard form. We don't call it scientific notation form, it's called standard form. We have expanded form, which we'll talk about also. But scientific notation or standard form. Remember, scientific notation is always a number between 1 and 10. A is a number between 1 and 10 times 10 to some power. K is some power, or some integer power. Our number system is based on 10 because 10 ones make up a 10, 10 tens make up 100, 10 hundreds make up 1,000, right? So our number system is based on 10. So when we do that, we can take everything times 10, and therefore that's why we use the power of 10. 10 to the first power is 10, 10 to the second power is 100, 10 to the third power is 1,000, and so on and so on and so on. That's the reason we can get away with using just the powers of 10. Now, this should all be reviewed. The rest of this, what we're going to talk about, you need to be able to convert to and from scientific notation. If I give you a very large number or a very small number, you should be able to convert it to or from scientific notation. All right? So, writing in standard form. In other words, when it says write it in standard form, that means to write it in scientific notation. 37,600. Where is the decimal point right now? Well, you're going to say it's not there at all, Mr. Miller. Well, you're right, it's not. But where is it? It's at the end. Where do I move it to make this number between 1 and 10? After the first non-zero number, right? So after the 3. So I have 3.7. I can write times 10. Automatically, you write down times 10. And it's times 10 to what power? Well, now, is 37,000 a very large number or a very small number? It's a large number. It's bigger than 1. So it's a very large number. So this is going to have positive power. How many places did I move the decimal point? 1, 2, 3, 4. It's the positive 4th power.
So at this point, class, what do you think is going to happen with question B? That's your first question for today.
It was done by scientists in Europe first. All right, let's go on. Let's change these standard form numbers into ordinary or normal form numbers. Okay, so I've got 3.2 times 10 to the second. How do I change 3.2 times 10 to the second without using a calculator? I don't want to use a calculator. I should be able to do this by hand. Taylor. Explain to me why. To make the number larger, I move the decimal point to the right, so that's 320. 2 places to the right, and add a 0. All right, how about the next one? How do I convert 5.76 times 10 to the negative 5th to a standard form? I shouldn't say standard. To a normal form number. Well, why? And what does a negative power mean? It's going to be small. So this should be 0.00000576. I moved it 5 places to the right. If I move 5 places to the right, it means I add 4 zeros. You always add 1 less 0 than the number. Because you have to move it around the first, you have to move it around the 5 first. Then you're going to add that number 0. You will be given at times 3.28 times 10 to the 4th times 1.47 times 10 to the 11th power and be asked to solve without using a calculator. You'll be asked to solve without using a calculator. On a test,
Class, how do you think we would go about solving this problem without using a calculator? Now I understand we can round 3.25 to 1 and 1.5, so we could multiply that without using a calculator, but the more important piece is dealing with those powers and the powers of 10. Go ahead and try to solve that now. Pause the video and take your minute to solve.
All right, let's continue on and talk about set notation. We did this last year towards the end of the year. We talked about set notation, so that we're going to go through this very quickly. Some number sets that you are going to be required to identify. One of the learning targets is that I can identify sets of numbers. So you should have written down somewhere in your notes what the natural numbers are, what the integers are, what this symbol means, what all the symbols are, what rational numbers are. You should write down all of the different types of numbers. What does the R stand? What does an R stand for in a number set? Reals. Okay, and we can have the irrational numbers. We can have integers. We can have natural numbers. So you should be able to identify all the numbers, all the different sets of numbers. All right, let's go on to set notation. Set notation. We went through this last year, right? So this shouldn't be anything new. Set notation is brackets. We identify the variable. This little red line means such that. So in this case, the set of all x values such that -3 is less than x is less than 2 is what that means. We could write it out in words, or better, to write it out in set builder notation or set notation. So for example, when will I be asked me to do this? If I give you 3x plus 8 equals 17, and they ask you to solve. So you go through the process of solving, you get 3x equals 9, x equals 3. You would write, instead of just x equals 3, you should write x such that x is equal to 3. And technically, now this is the abbreviated form, we should really write x such that x is an element of the reals when x is equal to 3. You should identify the number set that it belongs to. Here, they must be assuming that it's the real number.